Okay, so this is really one of the key uses of logs is to solve equations like this. Let's say I have 3 to the x equals 100. So I got 3 to the x equals 100. And I'm going to solve this in 3 ways. I'm going to do it with log base 3. We'll do it with just good old log, which is log base 10, and then with ln. Okay. So one of the things that kind of indicates that I can't solve this in normal ways is if I look at the bases, the 3 and the 100, well, there's no common base. There's no common base to those numbers, and that's typically an indicator that we want to use logs to solve my exponential equation. So remember, it's exponential equation because I got my variable in the exponent. Okay, so if I do this using log base 3, there's actually a couple ways I can do this. There's actually one way I know how to solve it already, which is if I have something in exponential form, well, I can transform it, right? I can transform it to my log form. And when I do that, the base of the power becomes the base of the log, and I'll get log base 3. And then I switch the role of the input and the output. So I'll get log base 3 of 100 equals x. And that is my solution, like x equals this, log base 3 of 100. But let me show us, another way I could get the x. I could isolate it. So a really common strategy when I have exponential equations is to take log of both sides. So I'm going to take log base 3 of the left-hand side and then log base 3 of the right-hand side of this equation. So the left-hand side is 3 to the x, the right-hand side is 100. Okay. And when I have log base 3 of 3 to the x, well, we've seen stuff like this before. What does this mean? The base of the log is 3. So I'm asking myself, well, 3 to what power will end up equaling this thing? Will end up equaling 3 to the x. But of course, the exponent's just got to be x. Okay, so that side just becomes x. There's also a log property I could have used to get that. Because if I have a log on the outside and then inside I got an exponential thing and the bases are the same, they cancel each other because they're inverse functions and you're just left with the exponent. Okay, so either way I'll get x. And on the other side I got log base 3 of 100. And now x is isolated, so that's my answer. It looks a little weird, but that is my answer. So what does this mean? That's a natural question that we might have. Like, what is log base 3 of 100? How big is it really? Well, if I look at this equation that I was solving, 3 to the x equals 100, this x that I'm after is the exponent. Let's try to get a feel for how big that exponent is. So I'm trying to make it become 100. So can I bound 100 in between two different powers of 3? So the 3 to some power and the 3 to some power? Well, yeah, so on the smaller end, if I do 3 to the 4, I know 3 to the 4 is 81, and that's a little bit smaller than 100. But if I up the exponent to 5, and I work that out, that's 243. So 100 is in between those two values. So what that means is, well, log base 3 of 100, which is representing this exponent that I'm trying to solve for, well, it's something between 4 and 5. This exponent, this log base 3 of 100, it's some 4 point something something. Okay. All right, let's do part B. So in part B, I want to show, well, how can I solve this using just log base 10? Now let's take log of both sides, log base 10 of both sides. So log of the left and log of the right. So I'll get 3 to the x inside here and then 100 inside here. This time, the base of my log is 10, and that does not match the 3. So they don't just cancel like I had before. But I can use the power rule to bring this x out in front. And if I do that, I'll get x times log of 3, x times log of 3 equals log of 100. Okay, I don't have to worry about any sort of domain issues in this problem when I do that because, well, 3 is clearly positive. And if I do 3 to any power, that's clearly positive. So I haven't changed the type of number I'm plugging in by moving at that power. Okay, and now, well, I know what log of 100 is. Log of 100, in fact, let's simplify that. Log of 100 that's asking myself 10 to what power equals 100, and that's just 2. Okay, so now I can divide the log of 3 over, and I get x equals 2 divided by log of 3. And that is also a totally fine way to write the answer. It looks a little different than this first way, but we'll show in just a minute that they're actually the same. Okay, but first, let's show, now let's do this thing with ln. So if I instead took ln of both sides, so ln of the left and ln of the right, I can do that as well. So ln of 3 to the x equals ln of 100. I could do it with any log base if I wanted to. Okay, but doing it with this one, again, I can pull this power out in front. So I'll get x times ln of 3 equals ln of 100. This time I cannot simplify this one. And then I can divide ln of 3 to get x equals ln of 100 divided by ln of 3. And that also is a totally valid way to write my answer. Again, it looks different from the previous two, but I'm about to show now that these are actually all the same. All right, so I'm flipping the page here. And to show that they're actually the same, I'm gonna rewrite the first answer, log base 3 of 100, using change of base. So first, I want to just review how that works by changing the base to some arbitrary number. So when I do change the base on log base 3 of 100, what I get is I get a fraction, and I get a log on top and a log on the bottom. I get to make the base be whatever I want, as long as I pick the same thing on the top and the bottom. So part A says, let's change the base to b. So let's do log base b on the top and on the bottom. And remember the memory trick for knowing what goes on the top and what goes on the bottom? It's these two numbers that I see here, and the one that's written higher up on the page, which is the 100, that goes on the top. And then the one that's written lower on the page, which is the 3, right? Because that's a subscript that's written lower on the page. That goes inside on the bottom. That's just a memory trick for remembering that. Okay, so that's what it would look like if you change this using change of base to b. Okay, so part B says, well, now do that, but let's change the base to be 10. Okay, so that'll give me a fraction on the top. It'll give me a fraction. Now I'm going to get log base 10 on the top and log base 10 on the bottom. And when the base is 10, I don't need to write it. So I don't need to write it. And using my memory trick, 100 goes on the top, 3 goes on the bottom. But I can simplify this because log of 100, I know what that is. That's just 2, right? Because 10 to the 2 equals 100. And then log of 3 just stays. I cannot simplify that. Okay, but I got it. I've just changed the base to 10. So we've just shown that log base 3 of 100, well, that's actually the same as this. The same as that answer we were getting. Now for the ln one, well, let's change the base to e. And if I do that, I'll get a fraction. And I'll get a log base e on the top and on the bottom. But log base e, that's just ln. So we get ln on the top and on the bottom. And I get 100 on the top. I'll get 3 on the bottom. But that's precisely the answer we were getting in part C before. So we've now shown that log base 3 of 100, well, it's this as well as that. If I just use change of base to change it to different bases. Okay. So one of the things that this means is the answers that we got to that previous problem are all the same. So when we want to solve exponential equations like this using logs, because there's no common base, well, we could use any log base. Any log base will work just fine. Sometimes some log bases are a bit easier to use. Like I would say this one in some ways looked the simplest. But often we like using log base 10 or ln, especially because calculators can handle log base 10 and they can handle ln.